Welcome to the deep dive. Today, we're exploring something pretty revolutionary. It's an energy solution for cities like Jackson, Mississippi. A place dealing with lots of sun, but also, well, tons of rain.
Yeah, heavy rain.
Exactly. So imagine turning that rain, usually a challenge, into an energy asset.
Right.
We're diving into rain-powered solar.
And what's really fascinating, I think, is how Jackson's climate just aligns up perfectly for this. You've got the sun for regular solar, sure, but then you have that intense rainfall. And, well, thinking back to issues like the 2025 water crisis, it just highlights how much reliable energy matters there.
Absolutely.
So this deep dive, it's really about how this cutting-edge tech could boost energy security.
Okay, let's unpack that. How exactly do you get power from rain? It sounds a bit sci-fi. We're talking hybrid solar technologies, right?
That's the term, yeah.
Right.
But let's break it down. So the key innovation is mixing standard solar panels, the PV ones you see everywhere, with something called triboelectric nanogenerators. The TENS, for short.
TENS, correct.
Right. And these TENS, they basically convert the mechanical energy of raindrops hitting a surface into electricity.
How? Like, what's the mechanism?
Well, think about static electricity, like rubbing a balloon on your hair.
Yeah, okay.
That's the triboelectric effect. So when raindrops hit a specific material, they often use PTFE, which is basically Teflon.
God, Teflon.
The drops transfer a positive charge, and that, combined with something called electrostatic induction, lets you capture that charge. It creates a, real electric current you can measure.
Wow.
And the newer designs, like these bridge array TENS, they can get peak outputs around 200 watts per square meter.
200 watts per square meter?
That's
quite a bit, isn't it, in the rain?
It is. I mean, think about it. 1 square meter could power several LED bulbs or charge, a few phones, even when it's pouring.
That's incredible. So what does this actually mean for a city like Jackson, then? How does it fit together?
Well, the really clever part is you can put a transparent TENS layer right on top of the normal solar cells.
Oh, so it doesn't block the sun.
Exactly. It lets the sunlight through, but it also catches energy from the raindrops. So you get this boost during storms or even just on really cloudy low light days.
Okay, so it's adding power when solar might be struggling.
Precisely. And actually in very rainy places, the TENS can sometimes outperform the PV cells when it's wet. We're talking maybe 40.8 milliwatts per square meter from TENS versus about 37 from PV in those conditions. So the real genius here isn't just making power from rain. It's about making energy systems more resilient, keeping the lights on during a storm when the grid might go down.
That sounds like a huge deal, especially somewhere prone to outages. But, new tech always raises questions. Jackson gets, 211 sunny days, but also a lot of rain, 1,400 millimeters.
Yeah, it's a mix.
So how feasible is this? And what about the practical stuff like cost, durability? If you, our listener, were thinking about this.
Good questions. And it really does tackle Jackson's big issues, aging infrastructure and needing reliable power. Now, the main power still comes from the sun. A, say, 10 square meter solar array might give you nearly 15,000 kilowatt hours a year.
Okay, that's substantial.
The Tang part adds maybe around 280 kilowatt hours a year on top of that. It sounds modest, right?
Yeah, compared to the solar part.
But that 280 kilowatt hour comes precisely when you might need it most during those storms, those potential grid outages, which, happen in Mississippi. It's about critical backup, resilience.
Building resilience, I like that. Okay, so we see the potential, but let's talk brass tacks. Cost, and importantly, durability. How long do these things last, especially in humid, stormy weather?
Right. Durability is absolutely key. So cost-wise, adding the Tang layer puts about maybe 50 cents per watt onto the installation cost.
Okay.
But you've got federal tax credits like the 30% one, and Mississippi has net metering policies. Those really help the economics, the return on investment over time.
Makes sense.
And on durability, this is where local innovation is stepping up. Jackson State University is actually doing some fantastic work.
Oh, really? What are they doing?
They're developing these moisture-resistant perovskite solar cells. Perovskites are another type of solar material, very efficient, but sometimes sensitive to moisture.
Right.
But these new ones maintain high efficiency even after being exposed to humidity for a long time. That's a huge deal for making this tech truly last in that kind of climate. It's boosting durability and efficiency.
That local R&D angle is really interesting. So looking ahead, if this is going to move beyond just Jackson, what needs to happen? Policy, more research, community action.
It's likely a mix of all three. I mean, broadening the scope is crucial. The white paper we looked at talks about putting these hybrid systems in critical places first, like hospitals.
Makes sense. Using federal infrastructure grants, maybe?
Potentially, yes.
Yeah.
It also recommends things like community solar programs, to help subsidize installations in lower income areas, make it more accessible.
Good.
And definitely continued investment in research. We need scalable ways to manufacture things cost effectively. And maybe even using like AI to optimize energy management based on predicted rainfall, making the whole system smarter.
So it's clear this rain-powered solar idea isn't just some cool tech gadget. It's really a strategic move. It addresses energy poverty, boosts grid resilience. It's turning Jackson's specific climate challenge into an actual advantage.
Exactly. It really positions Jackson potentially as a kind of model for sustainable energy in the Southeast. It proves that, with the right investments, the right policies, a city can adapt and even thrive, rain or shine.
Powerful message.
It really makes you think, doesn't it? What other sort of overlooked things in our everyday environment might hold the key to powering our future?